Welcome. Thanks for joining us for our AI-powered webinar. Please stay on mute. A couple of housekeeping things. Please stay on mute until we're at a question and discussion point. You can also put any questions in the group chat or Q&A. You can send them to us privately, or you can do that publicly as well. If you don't know who we are here at Certiverse, we are an end-to-end self-service exam development and delivery platform. So today I'm going to hand it over to Reese to introduce himself, and then Neil, you can introduce yourself as well, and then we can end up with me, and I'll go through the next couple of slides. Reese?
Sure. Hi, everyone. Thanks for being here. My name's Reese Butterfuss, and I'm an AI psychometrician at Certiverse. I've been here for about 2 months, and my job is to use AI to make the exam development process more efficient.
Thanks, Reese. My name's Neil Wilkinson. I'm the Director of Product and Innovation at Certiverse. So I'm in charge of prioritizing what happens in the tool and working out better ways to do test development and test delivery in Certiverse. I'm based in Manchester in the UK.
And I'm Esten Attieh. I'm Vice President of Certification here at Certiverse, and I've been in the assessment industry nearly 25 years now, working in all different kinds of roles, but spent a lot of time reining in SMEs in previous days. But I also currently work in sales, and so I hear a lot from our clients as well, clients and prospects. And so that filters into this and how we're going to address that in today's session. So this is how we build this session to you all, exploring how AI is transforming the way we review and refine exam items. And what we really wanted to do is take a look at a research study that we did internally with a Certiverse exam for Certiverse employees. And so we have the results of that study, and we'd like to present those to you today and talk about what's next and how we can maybe streamline things and make things easier for all of you in the industry. So a simple outline for today, we just want to discuss the current challenges, which I'm sure you all will be very familiar with. I'll talk about some things that I hear from clients and prospects. Neil can talk about some things which overlap quite a lot that you hear from people requesting that we can update the product to kind of address some of these challenges. And then Reese will go through the research study, a lot of meat in there, and we can talk about what's next. And that'll be a lot of what Neil has to say about how we can update our tool, or how we are already using this information to update our tool to make things easier for you. So, current challenges. In a lot of conversations that I have from a sales perspective, I hear that finding SMEs is difficult. SMEs have their own jobs. They're not just SMEs. So just finding the SMEs is a difficult thing to do. And then training those SMEs is very, very time consuming. And they're there to be content experts. They're not necessarily there to be do we really need to train them in all aspects of test development? So, Neil, I know you have a lot of feedback as well that you hear people requesting how we can transform the product.
Yeah, exactly right. So I've been in the industry for a long time, and I had a previous role where I was responsible for creating loads of different types of exams. And yeah, you're absolutely right that finding SMEs is like, I'm not going to say it's the #1 challenge, but it's really high up there. Like you say, it's really hard to find SMEs. It's really hard to find good SMEs, and SMEs, they've got other stuff going on in their life, right? They've got jobs and they've got life and family and holidays and things. Like, they can't dedicate full time to creating question content, and they can't necessarily hit the timescales that you need to. We've all been in those places when you're trying to create assessments where you have really fixed timelines and you have to get it done by a specific date, and it's really hard to find SMEs that can do that sort of work. In a previous role, I often said that the kind of critical thing to make an exam work is often finding just 3 good SMEs. If you have 3 good SMEs, then you can like really fly through creating content and reviewing content. But boy, finding those 3 really good SMEs is a challenge. Even though it's such a small number to make a successful program, or it can be, it's still really, really hard to do. And also, like you say, finding an SME that's like an expert in creating the content and is a real subject matter expert, but that also understands like how to create a good question, that understands like how to create questions that are in simple English and not misleading, how to create questions that are consistent in terms of style and grammar. Like you're expecting your SMEs to do an awful lot, and very few people have that kind of skill set to do all three. It's a fairly unique skill set you're looking for in your SMEs.
Yeah, so it's not just content, like you're saying, you're training them in the test development process. And then you're, as you said, expecting them to have maybe a style guide that they keep in mind, grammar, punctuation, all that sort of stuff. And first of all, to find those skill sets all in one person is difficult. But why are we asking them to do that, to do all of that, if there is a better way? Yeah.
Yeah, exactly that.
Yeah. Next slide. And so, yes, we talked about here the style and grammar reviews, but an important piece here is that errors in exams can affect company reputation. So it's a reflection on your brand. So that's an important piece as well.
Yeah, and the other thing there, it's a reflection on the brand, but it's also a reflection on the sort of value of the certification. You know, your people taking these exams, they've trained hard, they've studied, they've learned things, and if they go and sit an exam and it's got errors in it, it just kind of affects how you feel about the qualification that you've trained for and studied for, and are kind of showing off to your next employer that you've got. If you thought it wasn't high quality, it just affects how you feel about it.
Exactly right. Yeah. So the research study, the real meat of the presentation, I think. Reese, why don't we turn this over to you?
Sure. I will walk through what we did and what we found. So to provide some context, as we've talked about, item writers are generally content experts or subject matter experts, but they generally aren't test development experts. And we do our best to train them, but item writers are going to make mistakes or introduce flaws into the items they write. And for that reason, item review and revision can be the most laborious aspect of test development, and it involves a lot of repetitive labor from the SMEs. And then even skilled reviewers often miss subtle flaws in item quality that can affect the usefulness of the item and the information it provides. So our goal is to use AI to reduce that repetitive labor that SMEs have to give during item review and revision. And as a first step, we need to see if these large language models, if AI, can find the same flaws in test items that humans can find. So we can go on to the next slide. Thank you. So, I've come up with this example item to highlight a few of the common flaws we see in items, and these are all very exaggerated. They're in practice usually much more subtle than this. So the question is, and think about as I'm reading this, what you can pick out as the flaws. So what are the main effects of chronic sleep deprivation or insomnia? Option A is gum disease and tooth pain. Option B, which we call the key, or it's the correct answer. It's bold, but it's kind of hard to see that. It's sleep deprivation impairs memory, weakens the immune system, and can lead to cardiovascular issues. Option C, extreme thirst and unexplained weight loss, or option D, tremors and increased perspiration. So I think, it might be the case that some of the very obvious flaws are already jumping out at you, but here they are. So this item has an unclear stem, meaning, we could say this item is double-barreled. It's asking about chronic sleep deprivation or insomnia. And those two have a causal relationship, right? Insomnia can lead to chronic sleep deprivation, but they're not exactly synonymous. So that leads to ambiguity about what the question's actually asking. And it could be the case that some test takers are answering this question more with sleep deprivation in mind, and some are answering the question with insomnia in mind, meaning they're not actually even answering the same question in principle. So it creates ambiguity about what you're asking, and it makes it much harder to choose which answer is correct. This item also has a conspicuous key. In other words, the key, the correct answer, jumps out for reasons that aren't related to the content. So namely, this key is much longer and more complex than the distractors. The distractors are, A, C, and D. And it's the only option that has direct overlap with the STEM, right? It repeats the term sleep deprivation, which provides a cue to any test-wise examinees that this is the correct answer. So it just makes it easier to choose the correct answer without having the required knowledge to do so. And then the final flaw in this item, I would say, is implausible distractors, particularly distractor A, gum disease and tooth pain. It's hard to make an inference about why that would be related to sleep deprivation. Then you could also argue that C and D are relatively implausible too. Implausible in this case means that you can rule them out, like they're so obviously wrong, you can rule them out without having much domain knowledge. So if you can rule them out, it means they're not viable as options, and it just lowers the amount of information this item gives you about that test taker's knowledge. So again, our goal is to see how well AI can identify these item quality flaws with the ultimate goal of reducing the labor burden on human reviewers. And I also want to note that throughout this process, if there are things like grammatical issues or syntactic issues, the AI is more than capable of finding those too. We're focused more on deeper quality issues that influence how useful the item is. So we can go on to the next one. Thank you. So for this study, we had a psychometrician, namely me, go through 43 real exam items. And these items were part of Certiverse's remote proctoring specialist exam. It's an exam we're developing to certify people to do remote proctoring for exams. And all 43 items were 4-option multiple choice questions with 1 correct answer. And for the review process, I went item by item and I picked out which flaws were present in each item. And I was extremely fastidious and picky because I really wanted to challenge these large language models. I think I noted errors that a lot of SME reviewers probably wouldn't have picked up on. They're very subtle, some of them. Of course, there are also obvious errors that anybody would pick up on. And I also want to note that an item can have multiple instances of the same flaw, especially in the case of implausible distractors. So it could be the case that there's only one of the distractors that's implausible, 2 of them, or all 3 of them could be implausible distractors. And that would count as 3 separate instances of that type of flaw. And then, to get a sense of the error prevalence throughout the entire exam, I just summed the number of each type of flaw across all 43 items. So we can see that in the next slide. So across all the items, I found 107 flaws, the most common of them being implausible distractors, or distractors that are so obviously wrong you can rule them out without knowing anything about the topic. Conspicuous keys, so the key jumps out at you, or an unclear stem, meaning it's ambiguous what the question's asking, or it can be interpreted in multiple ways. However, there were some that were relatively rare. Like a superficial question, meaning it's a question that's not actually asking it's not asking about any important knowledge in the domain. Distractor clarity, it's hard to know what the distractor is actually telling you, and then so on. But they're so uncommon that I'm really going to focus on the common ones: implausible distractors, conspicuous key, and unclear stems. I also want to note that this is 107 flaws across all 43 items. There was only 1 item out of 43 that I did not find a single flaw. That's how picky I was in this instance. So I want to reiterate the goal. It's to test whether these large language models find the same flaws as human review, in this case, psychometrician review. And to do so, we compared 2 large language models that really capture the current state of the art, and that's GPT 4.1 and GPT 4o. And if you're unfamiliar with like the basis of large language models, they are trained on massive data sets of real world language, like for example, all of English Wikipedia. And they take the language you give it, and they're fine-tuned, or they're pre-trained to recognize statistical patterns in language with the goal of predicting the next word. And this allows them to do all the things we use, like ChatGPT for answering questions, finding errors in this case. And so these two models, they differ in their strengths and weaknesses. GPT-4o is faster and more efficient. Just by nature of its architecture, it's more sensitive to context. It's better at using context you provided longer ago in its current information processing. And it can handle multimodal input. In this case, all of our input was text, but if the items had images, for example, it could derive meaning from those images. GPT 4.1, on the other hand, is better with highly structured or like rubric-based tasks. And you could argue that finding flaws, you could see it that way. It's trained and optimized specifically for text, so it cannot handle multimodal input like GPT-4o can. And it's more deterministic, meaning if you ran the same task multiple times with the model, your results will be more consistent, right? There's less sort of randomness baked into the model. So then because, the strengths and weaknesses differ between these models, it's hard to have a hypothesis about which one might better match human judgment. So, for this task, you have to give the large language model a prompt. And if you haven't used LLMs before, a prompt is just the input you give to the model to generate a response. And good prompts, especially for complex tasks, are clear and unambiguous. They provide the relevant context. What are you looking for? If you want the model to simulate a role, what is that role? You're an expert item reviewer. Are specific in the request. You don't, your request isn't too grandiose or vague. And the good prompts use literal language. We as humans use figurative language all the time without realizing it. And that can throw off a large language model. So it's important to keep your language very literal. And then I provide an overview of how we specified our prompts to do this. We asked it to evaluate the items for quality issues. We asked it to check all the components of the items for various criteria, and we defined what those criteria are. We said, here's the definition of an unclear stem, of an implausible distractor, and so on. And we provided examples where necessary, just to give the model more context and information to grab onto. And then we also asked for a feedback on the item. What flaws did you find? And we also asked for a revised item. So if there are flaws in the item, then revise the item. That's more work for down the road. We're focusing mostly on the errors it found, but the ultimate goal is for the model to be able to automatically revise the test items, and in doing so, then address all the flaws it finds. So the output we asked for is a description of the quality issues, recommendations for improvement, a rationale for why it thought those quality issues were there, and then a revised item. And then just for fun, I included the entire prompt. I'm not going to read this, but if you want to see more specifics, you're welcome to go back and look at this. So here's an example of the output from the large language models. It gives you comments about all of the components of the item. So it talks about if the stem's clear, if the distractors are plausible, if the key stands out, and so on. And then it gives you recommendations. And this is what I read through to code to note which errors the large language models found, which flaws the large language models found in the items. So in terms of our results, I have this table again with the frequency of the different flaw types. And then I have GPT 4.1 hit rate and GPT-4o hit rate. In this case, hit rate means of all the flaws I found, how many are the large language models finding? So what we can see here is that for the most common flaw type, implausible distractors, I found 59, and GPT 4.1 found 93% or 55 of them. So it missed 4. GPT 4o, missed more, missed 11. For conspicuous key, meaning the key jumps out at you, I found 27, and so did GPT 4.1. So it found all the errors I did even though I was very picky and I chose even very subtly conspicuous keys. GPT-4o, relatively underperformed, still finding most of them, which is good. And so on. And unclear stems, again, GPT-4.1 found them all. So I think what's good to note at this point is both models, and I think any large language model is going to find very obvious flaws. So I think really where this difference between the two models lies is in the more subtle flaws that I found in, me being so picky when I did the review. So I think a summary is that LLMs generally missed few of the flaws that I found. However, on the flip side, these large language models did have some false positives, meaning they thought there were some errors that I did not think were errors. So I think to be specific, both models returned 15 instances where they thought there was an error, where there actually wasn't an error by my judgment. I did review those false positives where I thought there was an error, but there wasn't, and I was never convinced enough to change my opinion. And in the case of item review, false positives are much less consequential than false negatives, where it's missing mistakes. So it's easy to disregard what the model's telling you if you don't agree. It's much harder to have to review all the items again because you realize the models are missing mistakes that are actually there. So that's why we focus so much on hit rate or reducing the false negatives. And then, GPT 4.1 found more of the flaws, especially more of the subtle flaws that I identified in my review than did GPT 4o.
Hey, Reese, just a quick question, and I think it might be worth just reiterating this as well. So the exam that you were using was a Certiverse exam about remote proctoring. So the content is fairly, it's niche related to the Certiverse product, right? It's not like it's not like this is an exam that was, an English exam where there's a mountain of content out there and some really obvious answers. It was very much related to a fairly niche topic, and it was still extremely successful in finding problems.
Yes, that's a really good point. And we thought it was good to use a relatively niche exam because it presents like kind of the hardest case scenario for these models. If it's more of a general world knowledge test, the models will only do better. So the more niche the topic, the more specific the errors will be. And I think, even the best model, 4.1, did miss a couple instances. And I think that's just modeling the same difficulty any human would have in finding these errors in such a niche topic. So the takeaways from this work that I hope you leave with are that LLMs, in this case, especially GPT 4.1, show promise for item review. And this is even without fine tuning or something called retrieval augmented generation. So you can fine tune models for your specific task and to be more sensitive to your context. Or you can use retrieval augmented generation or RAG, and you can feed the model a specific knowledge base about the topic that it can use to return responses. So that would, I think, even improve. And in the case of RAG, and I think it could actually find content problems with the items rather than just item writing flaws, which could be another future direction that I think is worth exploring. And then, in this case, GPT 4.1 and also GPT 4o, they over-identified flaws. Like I mentioned, they indicated that flaws were there when there actually were not flaws in the items. But again, I think it's important to emphasize that this is not nearly as consequential as the model's missing flaws that are actually there. I think in application, you're not going to know which items have flaws or not. So you're going to review all the items that the model thinks has flaws. And it's much easier to read an item and say, no, it doesn't have a flaw, than to realize that it's missing flaws. And you have to review all the items again anyway. So this, again, was just the first step in a much longer endeavor to use LLMs to revise items. So these results come with the caveat that this is a single exam in a single domain with a single item type. And I think in order to ensure the robustness and generalizability of this approach, we want to apply it to exams that belong to different domains and have different item types and see if the same high accuracy holds up across all those different situations. Another kind of immediate next step is to evaluate the usefulness of LLM's feedback. So if you're an item writer and you're creating items and you get immediate feedback on that item driven by these LLMs, how helpful would that be for your item writing skill, for example? In my experience, item writers tend to make the same mistakes over and over again on every item they create. So some item writers are just prone to writing conspicuous keys, or they're prone to writing, implausible distractors. And if you get immediate feedback as you create them, does it lessen the likelihood that you're going to carry those same flaws into every item you subsequently write? And then, the ultimate goal again is to test whether these LLMs can rewrite or revise items to address the flaws that were originally there without changing the nature of the question. So you can't change what the question's asking or what knowledge it's targeting, because these questions are written to satisfy a test blueprint that specifies what the test needs to be testing. So you can't deviate from that too much. So that's going to take some careful review, but we're very excited about that idea, because the ultimate goal is to save that precious me time and prevent them from using their labor on repetitive tasks, which then allows their time to be used for more important things like the big picture decisions and the big picture thinking that guides the development of the exam.
All right, great. Thanks very much for that, Reese. That was really interesting. So I'm going to talk to you a little bit about what we're going to be doing next and how we're going to take some of the results from Reese's study and implement them in Certiverse. So what this is going to look like in Certiverse, and these features are going to be coming fairly soon, are we're looking to change the item review process to provide instant feedback to the writers. As Reese was saying, I really feel like there's a lot of value in providing feedback to writers as they're writing. Yeah, they might continue to make the same mistakes, but at least you're telling them about it and they're getting instant feedback, and they're going to, I know some item writers and they might well decide to just ignore it anyway, but at least they're getting that feedback instantly, and then you can then decide whether they act on it or not. We really hope, so that's as you're typing the item and you're submitting it, you'll be getting the feedback about the sort of quality points on the item. I really hope that's going to go a long way in improving the initial quality of items to provide that feedback, and to the sooner you resolve these problems in your items, the faster your test development process is going to go. You're going to catch these problems early. You won't have to waste as much time in the review process kind of dealing with them, because they'll just upfront be in a better place, and that's got to be how we do this. What we might then also do to kind of so that's providing instant feedback to the writers at the point they're writing items. We could also add an automated step to review the item before it gets to a human reviewer as well. Imagine a kind of like first step review process where it goes to an AI prompt to make some suggestions before a human reviewer sees it. Those two things might work hand in hand, or they might be kind of configurable, so you could do one or the other. I think there's advantages in doing it both ways. I tend to lean on the give the feedback to the writer straight away and we'll fix it. But I also see value in having this as a separate, this is an AI review step that it's been through. I hope that both of those things will and Reese mentioned this, if we can reduce some of the repetitive time-consuming work, hopefully it'll free up SMEs to create better content up front. They have to spend less time doing things that they're not experts in, and more time really thinking about the subject areas, writing good questions, and not having to worry so much about how to craft good questions and good item writing technique. Your SMEs, they are really there to write high quality questions about the product, not to have to be experts in English language and test construction and item writing good practice. As Reese said, and I think this is where it starts to get really interesting in the future, is if instead of just providing that feedback, we just went ahead and revised the item and then said, you've written this item, here's what it looks like with these changes made. Would that create higher quality items? Would it provide faster writing? Maybe. And I think we're going to be doing some studies into how we go about doing that. I think there's some real potential there. Humans, they're always going to be really important to review this content. And I know we're not suggesting here that you're going to just take out all of your human SMEs and not have them do this work. But we sometimes we can be over reliant on how good humans are at catching things, and we're all human. We can all make mistakes, and you can provide feedback to writers, and they can choose to not do it, even though it's good feedback, or they can do the wrong thing, or they could introduce another error whilst they change the item. So maybe it makes sense to kind of create an automatic item revision and have that reviewed too. And so that's kind of my final point there, is that this review that we want to introduce here, we really want it to reduce errors and act as a kind of helper and support rather than replace all human effort in creating this content. Humans are always going to be incredibly important in reviewing and signing off your exam content.
Okay. We do have, I think it looks like a good bit of Q&A. Looks like a couple of these may have been answered already. One out. Were you able to update the prompt to lower false positive rate?
Yeah, that prompt was, iteratively developed. In general, that's how prompt engineering specification should go, is you write an initial prompt, take a look at false positives, false negatives, and then you revise, try to get a better balance. But there's always going to be that trade-off between false positives and false negatives. And we erred on the side of minimizing false negatives, which then naturally increases false positives.
And we have a question about, I guess this may go back to really how large language models work and the security behind them. We have someone asking, can someone talk about security issues? Are the exam questions then compromised and out for the public to possibly access?
No. No. However, it can be. Like, you would never want to give exam questions to ChatGPT, for example. So we run instances of OpenAI models using an API. You can also house private versions of these large language models, which then means that there's no possibility of data leakage. So you can use large language models in a secure way that doesn't run risk of compromising client data.
And we have a question. Have you performed this test with the more recent LLM models? Did you try other LLMs like Claude?
We haven't used Claude. We stuck to the OpenAI models. We could use models from, I suppose, like Hugging Face, or there's other proprietary models we could try. And really the choice comes down to a lot of times cost. You want to be cost effective, and there's new models being created every day, so it is hard to stay current. But that's why it's important to develop a flexible architecture where you can swap in any model you like as new models come available.
And we have, while Reese took great pains to be highly critical of the 43-question exam, does Reese perform at this level of critique for every exam? Or do you perform at a lesser level some of the time? So a real test might be to take an exam he reviewed that when he was not aware of the test, and then see how the LLM performs.
That's a good point. Mm-hmm. I like to think
overly critical.
As a psychometrician, I tend to be overly critical, more critical than most SMEs would be, because I have more experience in test development and item writing. But I agree. Remote test proctoring isn't so far out of my domain where I couldn't be considered an SME. I think if you were to give me a test on something I know nothing about, I could still probably find obvious errors, but there might be subtle content mistakes that I would totally miss. In fact, I'm sure that would be the case. And I think that's a good open question for how LLMs would fare against human judgment when the human's not a subject matter expert, or when they vary in their knowledge and experience in item writing. I think that's a really good point.
And we have, did you try having the AI review the same items multiple times? That's interesting.
Yeah, I think that's a really good future direction. And in fact, let's say, as we talked about, you write an item, it's submitted automatically for AI review, and then the AI gives you an updated item that addresses the flaws. Let's say you're not happy with that item yet. You could just regenerate the item again, maybe with some specific prompting. And hopefully that would, get the item into a state you're happy with. And I think that's along the lines of what that question's asking. So I think that's also a great idea. Thank you.
And did you adjust the inference parameters, or did you use the default parameters?
We use the default parameters for this, but you can always change, temperature. You can, any hyperparameter you can manipulate. I think it would be important not to do so in like an unprincipled way or arbitrarily. I think you'd have to have a strong reason to do that. In fact, like for example, a temperature, I wouldn't want to set it to 0 because if you were to regenerate these items, you would want some variation. If you set it to 0, you'd get the exact same thing. So I think you could always mess with these parameters, but I would want to be principled about it.
Yeah. Is it possible to determine diff with LLMs?
I'm sure there's been work on this. In fact, at NCME last year, it's the National Council on Measurement Education, I did see some work on this. I think it sounds promising. I mean, you can ask for an item review for things like item bias. However, the conventional ways of detecting diff, I'm not sure a large language model can handle. Like, for example, the Mantel-Hansel statistic or something where there's item response theory methods for detecting differential item functioning. But I'm sure that the item review would be useful for preventing differential item functioning in the case where items are, biased against a particular subgroup.
And this is an interesting question also. How long did it take you, Reese, to do the analysis versus how long did it take GPT to do the analyses?
It took me as a human hours to code to first of all do my coding, and then second of all code for errors I found, and then code for errors that were apparent in the LLM's feedback. Because we had two LLMs, so it's 2 separate rounds of coding, and then mine. It took the LLM. It took minutes to do this, so it's extremely efficient. And if you can get 90-something% hit rate in minutes, it's an enormous time savings.
Absolutely. And then one for you, Neil. Is Certiverse going to allow for flexible configurations on this when this gets implemented? Can we change review options, AI versus humans? And how soon can we see these features?
Yeah, so definitely flexible configurations. We're not going to enforce these AI features on you. It'll be like a kind of customizable workflow, really, something you can switch on and off. And yeah, it's coming soon. We're talking, weeks and months rather than years or anything. It's right around the corner, really.
So it'll be much like I would imagine it would be much like today in Certiverse, where you can, when you go to write an item, you can choose whether to use AI to assist you in writing that item or not. I assume it will be something like that when it comes to the review as well, right?
Yeah, that's exactly right.
Okay. And also important to mention, I think, Neil, you mentioned this in the beginning, but these are imminent. So we're already working on these. And also this will be rolled out to all Certiverse users. This won't be, just for new users, or it won't be a pay to play type of thing. It won't be an upgrade to your subscription, anything like that. That's all included. Not typically, always when we release new features or functionality, that's available across the board. So that will be available day one to everyone. I think we have one other question here. Did you use one single prompt to do all of the tasks, or was there a sequence of inferences for each task?
It was all baked into one prompt. You could use separate prompts. In fact, that's something that's worthwhile to test. I tend to treat a single prompt and a single large language model as if it's one person's opinion. So I think it's always good. I mean, we use a panel of SMEs because the variation in SMEs will sort of wash out, and what you're left with is more signal and less noise. And I think the same thing can happen with large language models, where you should be ideally using multiple prompts that target the same task and multiple large language models, and considering their results more holistically to allow the prompt-specific variance and model-specific variance to wash out. However, it's not always so feasible in practice, just because of cost constraints and maybe time constraints, even though it is a huge time savings. So if one prompt that you develop iteratively and refine, over iterations, can get you most of the way there, I think in a lot of contexts that's sufficient. However, in higher stakes cases, I think you would want a more robust approach that uses multiple prompts and multiple models.
And I think we have one or two more questions, which is good because we're almost at time. Are you collecting metrics on the time requirements of SMEs for question creation that can later be shared? I ask this because one key information when recruiting SMEs is a clear indication on the time commitment they should anticipate. It's a good point.
I think, I mean, to my knowledge, we don't collect time it takes to to create items. However, in my experience, it can be several minutes per item. And then, of course, the review and revision, which often has to happen in multiple iterations, just compounds the time it takes versus an AI item that takes seconds to generate and seconds to review and revise. So the time savings is so apparent. Do you really need to calculate it? In the case of when you submit your items to review and it's returning errors, humans, it's easy for a human to look at the errors the AI thinks is are kind of embedded in that item and decide if it's true and decide if it likes the feedback better than the original. I think it's a huge time savings, like I said. Mm-hmm.
One more question. When the two models offered suggestions for improvements, was one better than the other, or were they similar suggestions?
That's the immediate next step, is to evaluate the feedback the model provided in terms of which one's more useful. There's more considerations than just, is one more useful? Because is one more useful for what? We have to be really careful about what the criteria we're using to evaluate the feedback, what those criteria are. So we're still working on exactly how we're judging the feedback and how we're judging the revised items, which will inform how we implement it, of course.
Okay, I think we've answered all the questions, because some of the questions are sort of duplicates about time savings and that type of thing. So thank you very much for attending our session. I believe we're right at time. If you have any other questions, definitely feel free to reach out to us. We'd love to chat with you more, whether it's about the large language models, about what you might be seeing as updates in Certiverse, or just about Certiverse in general. We'd love to chat with you. So feel free to reach out, and thank you for joining us today.